Testing for ammonium ions. So remembering that ammonium ions are the NH4 plus ion. Now the test that we're going to do here is we're going to react them in such a way, in an acid-base reaction, in such a way that we will release ammonia gas. And then we're going to test for the presence of the ammonia gas, because ammonia is a base. And so we're going to use an indicator to notice that we're producing a gas with a high pH. The reagent that we're going to use is NaOHAQ. And what we're going to do is place 1 centimetre cubed of the solution of sodium hydroxide into the test tube, and we're going to add a small amount of the sample to be tested. So we're putting 1 centimetre cubed of our sodium hydroxide and adding a small amount of the sample to be tested. If the sample is a solid, use a small spatula measure. If the sample is a solution, use approximately 1 centimetre cubed. We're going to then warm it gently and test the gas given off with damp red litmus paper. So we're going to hold in the neck of the flask. What we're not going to do is dip the litmus paper into the chemicals, because we have put a base in there and it will obviously then change colour. We do need to bear in mind this needs to be damp so that it can absorb the vapours, the gases produced by the reaction, as it's held over the neck of the flask or the test tube. So what happens? So if we, for example, were using ammonium nitrate, so let's take ammonium nitrate, and we were using it as a solution, we would say that we had ammonium nitrate and sodium hydroxide, and we would make ammonia gas, sodium nitrate and water. Now if we were to turn that into an ionic equation, which is often quite a lot easier for these tests to have an ionic equation, we would have NH4 plus ions, ammonium ions. What we're testing for, we're using hydroxide ions to test for them, and we get ammonia gas and water. And it's that gas that we're going to test for. What would we see? Well, as that gas comes off, it's going to rise up into the opening of the test tube, and the red litmus paper will turn blue. We're proving that we've made an alkaline gas. So why does it change litmus? Why does the litmus paper change colour? Ammonia, which remember is not the ion we tested for, but the product of the reaction, NH3, is an alkaline. So we get the colour of alkaline, which is the blues on our indicators. Why is it necessary to use damp litmus paper? We need the gas to dissolve into the litmus paper and react with the litmus. So it would just pass over dry litmus paper. So the ammonia gas needs to dissolve to interact with red litmus paper. Can blue litmus paper be used instead? No, because blue litmus paper tests for acids and we're trying to test for an alkaline. So that could be, we would put it into a damp blue litmus paper for gases, acidic gases, or blue litmus paper into into acidic solutions, sorry. Okay, so the second of these two tests is the carbonate. Remember that a carbonate is a CO3 2- ion. What we're going to do here is use the property that carbonates are basic, so we're going to use an acid to test for them, e.g. nitric acid, but we could use hydrochloric acid, we could use sulfuric acid. We're going to use an acid to test for the carbonate. Place a small amount of the sample to be tested in the test tube. Again, if it is a solid, use a small spatula measure. If it is a solution, use 1 centimetre cubed. Add 1 centimetre cubed of the nitric acid, remembering the important bit is that it's an acid, not specifically that it's nitric. What would happen? Well, let's do that equation with sodium carbonate, for example. So sodium carbonate is going to react with our nitric acid. Acid plus carbonate makes salt, sodium nitrate, plus water, plus carbon dioxide. If we balance that, the metal, and then the anion, and then we can see that the carbons and hydrogens balance, we get this reaction. Now, what would we see? Well, we're going to see the production of the carbon dioxide. Again, let's turn this into an ionic equation. So we're testing for carbonate ions using any acid, and the acid is the H plus part of our HNO3, and that gives us carbon dioxide and water. We would see effervescence because we're producing CO2. Now, we could test that CO2 with lime water to prove that it is carbon dioxide, and it would go cloudy. The product gives rise to the observation is the CO2. When testing for the ammonium or carbonate ion, we can use either the solid or the solution, and these two reactions are classed as acid-base.